Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter. We've been working on expressions for a little while, and we have a parser that works for it. We have a main parser that does the bulk of the parsing, and then an operator precedence parser that does the rest of it, the infix expressions. We got that working late last time, and one of the things we found when we were testing is, oh wait, parenthesized expressions don't really work right. And we know why. It's a grammar issue, I hope, but we'll tackle that today. All right, so let's get over to the IDE. Okay, so let me just do a quick look at what we did. So we have the operator precedence. We have this precedence parser. Last time we modified it so we'll work with expressions rather than tokens, which are more classical. But the way we're working is the main parser produces expressions, but it doesn't know how to combine the operators. So the precedence and right associativity and so on, it doesn't know any about that. So the operator precedence parser can do it. And the reason, well, I don't know. I guess part of the challenge is we have like 9 levels of precedence in the grammar, and up until a couple releases back, I guess Elm lets you define user-defined operators with user-defined preference or precedence. And if you're doing that, you can't take the approach that says let's encode the precedence in the grammar rules, because you would need new grammar rules every time a new operator got defined, and normally the compiler has fixed grammar rules. This operator precedence parser lets you pass in a list of operators with their precedence associativity, and it can turn that into a valid parsing process. So it's much more able to handle a dynamic situation. Now Elm, my understanding is they've removed user-defined operators, probably perhaps on a permanent basis, as sort of not paying for themselves. But you can still see the declarations in the system operators. So we took a look at that the other day. All right, but at any rate, we have that there. And then let's go to our main parser here. Okay. We injected a level. So the main bit of parsing, if you can start an expression, we're going to go to a function caller definition, which parses a bunch of expressions, which could be a function call or it could be the first part of a definition. If it sees an equal sign, it knows, oh, wait, that was a definition. If it doesn't see the equals, it says, oh, it's something to evaluate. And so you can see here we parse for operator expression. And then if we see equals, we do the function definition and we're fine. Let's see. But in expression, that's the function stuff. Okay, here's our operator expression. Basically, you take the list of expressions while you see while you see an operator. So you see 3, and then you see plus. You go, oh, I'm going to grab the plus, and then another set of expressions, which could be a function call or something. And so grabbing these expressions, we ask, can you start an expression? And then down here we have parentheses. Left parent calls parenthesized expression. So you can see we still have 5 or 6 levels here. I just didn't want 10 more. Okay, parenthesized expression. It calls expressions and does its work up until it gets commas, which is all great, except that we'd like to be able to type parenthesis 3 plus 4 times parenthesis 4 plus 5. And this doesn't quite do it. So we should be able to write a test that demonstrates the error. Parser tests. Okay. So we did that one. Let's do kind of an equivalent test or a similar test. Operators and parentheses. Oh, excuse me just a minute. Oh, sorry about that. Okay, so if we wanted to do 3 plus 4 times, well, even this would be a little bit of a problem. Okay, so this would be 3 operator. I guess we would have the star on top now. And then we'd have this operator be the plus 3, 4, and then the times is grabbing 5. Put that comma back up here. Okay, so we're multiplying. The first thing we're multiplying is 4 plus 5, or 3 plus 4. And then what we're multiplying with against that is 5. All right. And this, I believe, will not parse the way we are right now. Okay. Failed, missing a right parenthesis. So the reason it thinks it's missing is because it doesn't know how to read. It doesn't know about operators. The expressions we're calling is assuming we're going to have one or more expressions followed by right parenthesis if it's parenthesized. But now it doesn't know what to do. So this, I don't think is going to be terrible. I think all we have to do is change this to be operator expression. I hope. If we've done things right. Okay, so operator expression lets us handle the ones with operators. Okay. Now where things could get a little weird, well, let's see what happens. I think it's okay. We got it here and here. All right. Let's run tests again with the intent that they pass. Oh no. Okay. Post order line 26. Oh. Well, let's see what the expressions are. Three values, 5. This is already looking odd to me. Expressions. Our expression sequence, I would expect to be 3, 4 plus 5 times, actually. Op functions, that's nothing. Okay, 0 is 5 star plus. Let's see. Well, this step was probably not justified. Let's simplify a little bit here. This is the case after a comma. Let me make sure we put that in the to-do. Okay. But where we're blowing up, I mean, this is post-order tree, so this is before. All right, now I'd assume. Well, one thing I know. Our parser actually, our precedence parser does know about parentheses, and maybe it's eating up one that it doesn't want to, or something like that. All right, so we are where? Okay, that's the right test. We're getting the parse. We call parse. Function call or definition. Yes. Operator expression. Yes. Whoa. Um. Well, let's stop on the way in instead and see what's going on. I would expect this. Sorry, let's just check out our test again. Is it a parser test? Yeah. Parenthesis 3 plus 4. See, my assumption was 3 plus 4 would get evaluated as an infix operator expression. The right parenthesis would come back out as part of this thing, and then we would do times 5 as if it were an independent expression, and no more issues about parentheses. Let's. All right. Yeah, so we're going to rerun this test. Now, one of the things we have to watch is that our next token always leaves things in the right place and all that. So, okay, so we're coming in. Let's see what token is right now. Okay, it's an int 3. Okay, so we are. How do we get an int there? I would have thought we would be calling parenthesized expression first. All right, let me run that again. If you can start expression, call function call or definition. Okay. Okay. Yeah, it's something like we're at a parenthesis to start with. I don't know why token is 3 though. Where are we? Okay, so print token 3. That really seems wrong. Okay, so we come in parse. That's right up there. We got a token. Okay, I'm going to back us up again. I got to make sure we're at the top of the problem before we get to. Oh, am I running the wrong darn test? Okay. I don't know. It's my day for doing that. I did it on another project like several times in a row. Finally realized. Okay, parse. Let's look at token. Yeah. All right. So, yeah, what's going on is we're we're using the parenthesized stuff. So our parser knows about parentheses, which, well, the reason I don't know, I keep we mentioned last time there's this notion of an operator grammar, and it's something that's got like term operator. Well, it's basically like we wrote up there. It's term operator term star, and the rule is you always have a terminal like operator, a concrete token, followed by a non-terminal like term, and you're always alternating between them. And if you have that pattern, then you can use this precedence parsing. Now the actual parentheses are okay, except Elm and our grammar don't agree on some stuff. And one of the things that happens in the current expression, well, I guess the parenthesized expression. So this thing allows comma, and so you can have parenthesis 3 comma 4 representing a tuple, and we don't know about commas, we don't know about parentheses that aren't really for expressions and stuff like that. Is all out of the realm of our precedence parser, and I think it maybe has to be. That's the thing I'm fighting here, because if we have fxy, that's well, if we have function of parenthesis 3 plus 4, okay, that's two things in a row, and it doesn't know, it doesn't have a guarantee about the operator being there, because you could have function of 3, or you could have function of parenthesis 3 plus 4 parenthesis, and how do you know, how do you know it's going to work? And I don't think we do. So I think what it sort of comes to is operator expression should not be. Well, no, am I mixing myself up here? Maybe we're okay. I mean, we come in with left parenthesis, we call expressions, we don't call our parser, precedence parser, until that whole thing is parsed. Okay, maybe we're okay. Boy, wouldn't it be nice to have a good visualization of the parser? Well, doing it this way isn't so conducive to it because you've got literal code here. But if you had it in tables, you probably could make a better case for that. And I don't know, this gets very repetitive after a while, so you could probably make a case for doing it in tables. But we're here. All right, so we're on our way down. We've got an expressions, and I think we've skipped so that we're going to start at, we'll get down to parenthesized expressions before we do anything else. Let me just put a break here just to make sure we hit the parenthesized one first. Okay, so we're here. We should hit parentheses. Okay, so we got, now we're going to skip over that token, and now we're going to call operator expression. Okay, so we'll step over. That's not encouraging. Step into. Oh, I added code, or I added stuff. Okay, we're back in operator expression. Now we're at 3 plus 4. We got rid of the right parenthesis, the left parenthesis. Okay, and if we parse expressions, all right, let's step in. I guess go over and in. All right, now if we look at token, we should be at the 3 still. Okay, good. We're going to parse the expression. And I think that should be straightforward. It should just pick up the 3. Token can start expressions. No, we have a plus, and that's not in our start expression list. Okay, so LA, we don't do that. It's not an error. Let's look at LHS. Okay, LHS is it's an expression type now. So it took the token 3 and it wrapped it up into an expression 3. And we can see the count is 1. So that's going to return our numeric expression. All right, so we'll go ahead out of here. Expressions. Okay. Now, yeah, we're back up here. We're saying, oh, while you're an operator, yes. And let's check out that method. Plus minus star times, no parentheses. Okay, so let's go back. All right, so I think we expect result will get a plus. We'll skip over the plus, and then we will get another expression, I hope. All right, so let's do it. This should be true. We append that. All right, let's look at result. Gets a little overwhelming. Okay. Result is a 3 and an operator plus, and there's only 2 values, so we don't need to look at the rest of the junk in there. All right, but that's all the tables of operators, every operator and stuff like that. So, all right, so we got 3 plus. We're going to append expressions, and I guess I'm going to walk in this one. It's good for helping us learn the grammar, but yeah, that's all you can say for it. All right, so we got 3 plus. We're looking for the 4. And we'll see an int. Skip over it. Oh. Skip out. Out. Next line. We're going to return an integer value. That's a good thing. Okay, so let's look at LHS. Oops. I type LHS, you turn it into LHS. Does it not exist yet? Okay, it's empty. And we'll step over. And it should have one thing in it now. Okay, it's got the 4. All right, so as of now, we have an expression with a 4 in it. All right, we have no more can start expressions, so that should skip over. That should skip over. Count is 1, so we're just going to return the thing. It's the number 4. All right, and we will append it to expressions result. All right, result has 3 values. Integer, which is going to be 3. Operator plus. And expression 4. Okay, so we got 3 values in our operator expression. That's all sounding like what it wants to be. All right, we'll step over. This should be false because it's a right parenthesis. The count is not 1, it's 3. We put in an end of file. I'm not sure this is the best place to do that, but it's what our precedence parser assumes it's going to have is a marker at the end of each expression. Let's print token. We expect it to be the right parenthesis. Okay. So, did this thing blow up? I'm going to return out. Well, post order of 3 plus 4 should be 3, 4 plus. And I don't know, there's not a good way to catch this, but expert now should be an operator, basically an operator tree kind of expression with the two children. It's a plus node with the left side 3 and the right side 4. Okay, so far this is all like I expect it to be. Okay, so we have an expert, it's not an error, and we're going to build a result. Okay, and our token is not a comma. Our token is a right parenthesis. Okay, and so we are okay. Now we've consumed the right parenthesis with this thing, so our token should be the star now. Good. Okay, so we got parenthesis 3 plus 4, parenthesis. We're ready to do the star if we can get out of here properly. All right, so we don't know what the types are going to be. We've kind of ignored that for a little bit. There's one value in our result, so we return it, and it's a node now. Okay, so parenthesized expression is basically returning a plus 3, 4 tree, expression tree. All right. Now we're at the end of expression. We got that. Okay, let's continue. Expressions. Okay, we just did that, so let's look at LHS again. I gotta step over, I guess, first. Should be our tree, 3 plus 4, which is plus 3, 4. Yep. Okay, so where we are, we're in expressions. Token can start expression. We're at a star, so it should say no. Okay. Shouldn't be an error. Should be one thing in our LHS, and it should return it. All right, we're back up to operator expressions, and we have result, which is our first result, and it's the tree. Just carried through. Plus 3, 4. Okay. Okay, so we're at the times. Token is still times, star. So it is an operator, and we'll step over, and we're going to push the operator expression on the stack, skip over the times. Okay. And now we're going to get more expressions. I wish. All right, so we have our 3 plus 4 node. We have our plus node. Our times node, and we're hoping to get the node for the 5 by looking at expressions. So we'll step in and over. I hate to jump too far, but I mean, I think we're looking for a 5. The token is we're looking for an expression. The token is a 5. And LHS should just parse a 5. Let's make sure it does that. Okay, now that's another expression. Okay. Token is probably end of file at this point. Yep. All right, so we're not going to go in this while loop. Step over that, step over that. LHS count is 1. Return that. We'll go out. Okay, token is operator. We'll append that to result. And now token is operator should be false. Okay, and let's look at result. Hopefully you're expecting 3 things in there. Yeah, a long list. Okay, the first one is an expression node with plus 3, 4. That's all internal to it. The second one is an operator node, star. We don't use the left and right yet. That's a later job. Okay, and then an expression. So we have the 3 plus 4, and then the star, and then the expression. Okay. All right. We'll go over. We're appending the end of file. Now, okay. This. Okay. So at this point, everything is as I would expect it to be going into the precedence parser. Now let's go in. I was not expecting to do the grand tour like this. All right, so we have our input expression. That's what we just looked at, but just for okay. Well, input sub 0 is the plus 3, 4. Okay, it's an expression node. It's an operator. Okay. Yeah, I think I know what's going on then. We're using the same operator node for an operator with 2 unknown things and operator with 2 known things. So we kind of have 2 domains of operators. One is we parsed an operator token, and we just want to keep it around so we can do our precedence parser later. And the second is we parsed a sub expression 3 plus 4, and now we have an operator node that's sitting there with 3 and 4 underneath it. And so it comes in and it says, what's the precedence relationship? Let's see where it asks that. Yeah, expert to token. Right. So the problem is our stack looks like an operator. Right. Okay. So the expression is an operator. Well, this one is, but it really should be treated as a whole sub expression. The way we know the difference is LHS is nil and RHS is nil. Is empty expression. Boy. I don't know. I got 2 solutions. Always do. One solution is we check here and we see if it's really an operator token, meaning it's got, it's got empty stuff in it. Input sub 1. Okay. Yeah. It's this Whelm expression type error. This is our empty expression. We could explicitly look for that. The other alternative I could say is the operators that we make a separate operator token that handles that case. And then we would have operator token for in parser, let's see, is operator here, we would make this an operator token. And that's probably okay. Oh, let's see. Expert to token. I mean, really, we have to figure out how to make this thing work. Okay, let's find the tests for this. We'll do a stupid way. That's not even externally tested. Well, that can be fixed. Precedence Parser Tests. Okay. It knows. What does it know? It knows something about the operators. It knows real operators have empty RHS and L. I guess put them in the other order. LHS and RHS. Left hand side, right hand side. Okay, and so Precedence Parser. What does he expect? I think he wants a table, right? A precedence table. Well, this function really can be static. Maybe that would be the way to go. In which case we have to say precedence parser dot and same thing here. Okay, so well, I make that static. Make sure that doesn't break any tests. I want to be careful on this one. I guess we're expecting one failing test. Oh, nasty failing test. Parser tests. Let's take this one out of the equation. Okay, so if we don't really need the parser. Let's just do assert equal. And if you call precedence parser dot expert to token with an operator, and let's take token dot plus. If you do it like that, you should get I think token dot plus. Is that what that operator does? Gives you a token. Okay. And otherwise treated as a lowercase name. And let's get the other test the other way. We'll let value equal integer value of 3. And now if you have operator token dot plus and value, you don't really get that. You get token dot lowercase name of nothing. Okay, so the two cases, you have a true token plus operator representing a token, or you have a operator representing an expression. And I think I'm trying to get this right, and then we'll clean up. But I think this test will fail. The second one's going to have a problem. Okay, so this one came back with plus, even though it's a true expression. All right. And the difference we know is if you go to the operator, it's got a default on here. Let's take this default and we'll use it for now. If the expression is operator, all right. Let expr equals expression as operator. And then we can return expr down here. But before we do the operator, we're going to have to check. Whoops. Is this thing well, yeah, if expr.lhs is that and expr.rhs is that, then we can return expr.op. And otherwise we'll fall through to here and return lowercase name, and that's I think what we want. Right, now let's uncomment this thing. Run all these. Oh, okay. All right. Let's take a break, a couple minutes, and we'll come back and see what's going on here. What is this? Tree. Yeah, same issue. Okay, we're gonna have to do something about it. All right, see you in a couple minutes. All right, welcome back. So yeah, we have the same issue here. This post order thing is looking and it says, yeah, it's an operator. But yeah, but it could be the other operator. And you know, I think op equals expression dot op. Yeah, now we make a new one. Maybe let's go back. I'm gonna pick the other solution. Fickle, I know. Okay. What I would like to say is only operator token is treated this way. And regular operators, I think those are legit nodes. Okay, so we'll take this test out again. We're going to do the refactoring to change operator versus operator. Okay, and yeah, this is more than it needs to know. I mean, I think it needs to know. Well, I think it'll be so obvious once it's an operator token. Let's go over here. We're going, can I duplicate this? No. Okay, let me add in here. We'll just add a Swift file. And this was briefly working for me, but I think we're probably back to the weirdness. Yeah. Okay. Let's add an operator token. Move this up here. Okay, he's going to be very similar to this. So we're going to take this and use it as the basis. Now he doesn't need left and right. Op functions, he doesn't need that. He doesn't need any of this. These don't mean anything. Okay. The other as operator token, and the operator is equal. Evaluate doesn't make any sense. This is really an error case. Error expression, error messages. That. Okay. Nothing's referencing it, so that's kind of a neutral change, I hope. Okay, but now we have to be a little pickier here. So we're saying if the expression is an operator token, then pull this from the operator token, but this is producing a real operator. So this is the moment we convert from token to expression. Okay, that one's okay. Let's see the parser. Okay, so it's really, this becomes expression as, well, if we know it's an operator token, okay, we don't need the left and right thing anymore. And I think we can even do this. Let expression equals. Well, no, it's like case let. No. No. Let's undo. If expression is operator token, return expression as operator token. I think there's a better way to do this, but we'll get through this first. What we just did differently. That seems okay. Precedence parser, expression to token. I think that's okay-ish. Expression to token. Yeah. Expression to token. If expression is operator token, return the op. Otherwise, return lowercase name. Okay. I think that's what we need. There may be a couple operator token places, maybe in a test or something. 20 failures. Okay. Yeah, maybe in a bunch of tests. Oh. No, this seems okay. Maybe reverting here. Final class. Like, why is that highlighted? Test will import. Oh, okay. These, yeah, that's a legit change here. The input should be coming in as what are we doing? Post order. So post order wants operator tokens, input tree, and expects operators to be produced. Let's check this test. Okay. And probably the same thing here. Operators token in the input, operator in the output, operator token in the input. Those. Precedence Parser test. Parse variable x, we should get a variable x. Now that's odd. Unknown precedence between operators. Okay, this is the input. These should be operator tokens. This has not been a smooth changeover, has it? So I think the problem is it gets operator and it doesn't, it's seeing name, and doesn't work. Real operators, this is operator token dot plus should be equal to token dot plus. And this one, operator let me split this test up. Precedence token gets operator for operator token, and don't need this case then. And this treats operator as lowercase name. And we'll drop that. Okay, so I think post order tests should be passing now. One of those was a little weird. This one. Variable x. Oh dear. Okay, I've definitely taken too big a step. It's like, are we close to the end or are we way off is the problem. Okay, so I pass in variable x, variable y, and an operator token for double equals. I'm surprised it just failed. Oh no, it failed all of them. Okay, let's make this thing. Oh, he pressed print operator token. Okay, back here. How does this one pass and that one doesn't? Right? That's a little weird. Okay, operator double equals. Variable x, variable y, operator token should be our input to our post order. We get the tree out. We expect operator double equals. Variable x, variable y should be the tree and the expected. All right, let's just run this one test. Okay, let's there should be a place in the parser itself that does the wrong thing, but okay. Post order tests are green. That's good. Precedence Parser Tests. Now that one just seems way weird. Unknown precedence between operators. Operator token coming in. Oh, our parser. Does our precedence parser produce operators or operator tokens? Okay, end of file. Let's look for operator here. End of file. Expert to token. If the expression is an operator token, just return the token, the operator. Probably that name could be token. That. Wow. Okay, what's going on here? Unknown precedence. Expected. Oh, wait. Expected. Oh no, this is the parse only. That's the input. That's the output. That should be the case. Okay, let's find that simple case. We're going to step in to Precedence Parser Parse. It's my day for walking around the debugger, isn't it? Okay. Run this test. Now, what's odd? Let's look at input. Make sure that's what we expect. Input is a generic name we haven't interpreted. It's an X. And end of file. All right, and this should probably be operator token too, but we'll skip that for the moment. Okay, so we have variable end of file, right? That was a variable. Expression generic. Yeah, variables have names, so I think that's probably fine. All right. And the file operator. Okay, and top of stack and current input. So top of stack is the operator and a file. Current input is a variable, name X. Okay, so that's the configuration we expected at the beginning. They're not both end of file. Which is fine. Okay, so they should have a relation, and let's step in. Okay, and we'll print expression, which should be our variable. What? Expression is the operator. And a file. Okay. Oh, well, he's not an operator token. Yep, that's the issue. Okay. Let's make this operator token. And a file. And then in our tests, end of file is operator token, end of file. All right. Now there's still going to be something wrong in our main parser because it doesn't know about operator token yet. So 2 failures go by. Ugh. Okay, this one is parse unknown operator fails. Operator comma. Oh, operator token. That one's fine. All right, that's the only one. Had an expression fail up here. Post order and precedence parser should pass. All right, and the failure is this thing. Operator plus integer value operator 3, 4, 5. Yes, that's all good. Right, so I think our parser, let's find operator. Token.is operator. Yes. Operator. Yeah, our parser should be producing operator tokens. Not this empty expression stuff. And same thing here. Okay, well, not my finest half hour, but here we are. All right, so what do we got? Did we leave this commented? Where's our parser tests? Yeah, let's make sure this thing works now. This one we've never seen work yet. Till now. All right. Okay, let's commit. So we changed Precedence Parser to explicitly, well, it's both parsers, main and Precedence Parsers, to explicitly treat operator tokens separately from an operator expression to be evaluated. Yeah. Okay, well, not quite the next break time, but I think what we should be able to do is run it now and see parenthesized expressions working. Let's see, all we have is plus, minus, and times for functions. But that's enough to get started. Okay, so if we do 3 plus 4, 7. 3 plus 4, 7. 3 plus 4, 7. Yay. Okay. 3 plus 4 times 5 plus 2 should be 49, right? Okay. How about our pairs? Do they still work? Yeah. I think we can do 3 plus 2 comma 4 plus 5. Whoops. Something's still wrong with our commas. Yeah, I think what's going on, I don't know, I'm good at making up stories, right? But I think what's going on is when we go to parse 3 plus 2, we maybe don't get an end of file here. I don't know. Let's try a variation. 3 comma 4 plus 5. Well, we're definitely learning that internal error is not a super helpful message, huh? Okay, let's add that to our list before we go too crazy. Use operator expression after comma. We didn't do that yet. Okay. Parser. Well, let's make a test. Now, I don't know what we call those. Expression with tuple and parentheses. How about tuples with infix expressions? Okay, so this one is 3 plus 4 comma 5 is the case we had, like that. And I don't know what they produce already, actually. Let's go to our parser, and we'll go down to parenthesized expression. Down here, it's got a tuple. All right, so we should get tuples back. Parser tests. So we expect a tuple and I think he takes an array of stuff. This will be, I guess it'll be the operator 3 plus 4th bit. Tuple. One thing is an operator, another is an integer value. This should end the tuple. I think he needs a type. And let's number. We'll just assume it's number for now. Okay, you match parse. Got one extra one. Okay, 3 plus 4 comma 5 is a tuple operator plus 3, 4. Value 5. And type is number. And the type may not be, actually it's probably not. I don't know. We'll see what it is. I'm going to explore a little first, but we're not going to have the operator plus 3, 4 stuff, I don't think. Oh, operator plus 3, 4 is not equal to os plus 3, 4, 5. I'm guessing the type is the issue. And also our test needs to be the other way around. 3, 4. Tuple elm type dot tuple with types. Oh, interesting. Okay. We got a tuple type that really knows its stuff. Okay. So elm type dot tuple types is going to be elm type dot, I think number, elm type dot number. Okay. And I'll run it. Yeah, our message there could be better if it had the types with it too, because it's hard to see. I mean, it looks like it's the same, but let's step in. We'll just break here and step in. Check successful parse. Okay. The expected. Let's step over. And I just want to get details on actual. Elm tuple with 2 values. One's an operator. That's actually okay parse-wise. Op functions. I think our types are different here. Can I find it in here? Yeah, type is unknown on these. Okay. So unknown and int. I think if we do that, whoops. And that's reflecting that we don't handle types yet on our operators, which should go on our to-do list. Yeah, loose ends, I know. Okay, where's tests? Unknown type, and this one's a number. I think that's probably better. Yeah. All right, and then let's get the case that doesn't work. All right. This is infix expressions after comma. So let's flip it. Let's do 3 and then 4 plus 5. This should be integer value 3. Four plus 5. And now this one is a number, and this one is unknown. Okay. 3, 4 plus 5 should be a tuple. 3, 4 plus 5. This is going to fail because we don't handle the stuff after the comma. We started to I took it out because we didn't really justify it, so now we're justifying it. Okay, 3, 4, 5 is not equal to missing a right parenthesis. Okay, I think it's expecting the right parenthesis after the 4, so let's... All right, so parenthesized expression, operator expression. Now it should do the same thing in the loop. Instead of expressions, we'll do operator expression again. And I'm hopeful. All right, so now we allow tuples to have infix expressions. Okay. I don't know. It's very tedious. It's boilerplatey code, I guess, is the thing. So that's a legit problem. But it's probably the easiest one to just add stuff to, for what that's worth. Okay, let's check out to do. We've accomplished some things. Let's get that on our list. All right, we're still on the eternal story here. I mean, it's infix operators in a language that's built around expressions is not too surprising. All right, parenthesized expressions, operator expressions. We're going to save types for another time. Oops. That. I guess we'll leave that at the same level. Handle non-associative operators. We haven't dealt with that one. Semantics of remaining operators. Yeah, that's fairly straightforward. The semantics, we don't have something that handles the conversion. Like we have that convert to that turns a plus into a integer plus and real plus, but the other operators are just more complicated. But I do think handle non-associative operators. My parser books and the online stuff I looked at, nobody really explained how to do. The case we're worried about is A less than B less than C is illegal. Okay. Well, let's say is not allowed. Okay. Now, if we go to our precedence parser, well, actually, not the parser. Excuse me, the builder. Okay, so somewhere up here. Oh, that's the test. Here we have the associativity. Well, there's actually three associativities. One is left, one's right, and the other is none. And we don't handle none, basically. So I'm going to go back here. Okay. So I think trying to reason it out from principles, if there's no associativity, I don't think you should have any entry at all. So let's see. So if you have two operators of equal precedence and they're non-associative, if it's the same operator, non-associative, that should be an error. Yeah, anything with two equal precedence operators that are not associative, they shouldn't allow anything. So I think we'll extend this page. Let's make this copied. Okay, so I think we're adding another rule to our table. Let's see if I can insert a row here. Add row below. Okay, so we have a case of op1 equal op2. Associativity is none, and this is error. Error. Okay. Let's stretch this a hair. Page is getting full, but we're not going to reference it too much more, I hope. Yeah, associativity none should just be an error. So at some point, we have code that goes through and puts associativity for operators, and we need to add this case. Okay, so it's in here. Well, we're saying there should be a case none. Nothing handles it. I don't know if we're going to see some errors in this now. Interestingly, oh, there it is. Yeah, switch must be exhaustive. So we need to handle the case of equal precedence. Well, I guess if they have the same precedence and none, they'd have to both be none. If one of them's none and one of them's not, I guess it's legit to add the precedence in. Because if we had a plus 2 greater than a plus 3, we want that to be allowed. All right. So I'm going to copy this out, blank this out momentarily. All right. So somewhere we have tests for this thing. Precedence Parser Tests. No. Precedence Builder Tests is what I want. Clean up a little here. Okay. Empty list has initial non-operator values. Fine. Operator has a relationship to default cases. And this is trying to say in our table, plus is less than lowercase. Default cases. Okay, left associative operator relationship to self is greater and less. And we're going to add one. And we'll take the greater or less than. That's our starting one, right? Less than 8 and none, which doesn't exist. And this should be an error relationship. I don't know if our check, let's see what our check does. Operator relation is error. Okay. So yeah, we can do that. Less than none. So that says less than related error to less than. And these are like shouldn't happen. It's not can't happen. It's an error if you see it. Okay. And this needs to exist. And that implies, there it is. This case needs to be complete. And let's just add a wrong value for the moment. Okay, so it should be, well, it should just fall through. But everything defaults to error. Test should fail at any rate. Okay. Builder test. All right. Greater is not equal to error. All right. And this, I think you can just say continue. Not sure how you know. I don't know how to ask for this. Break. Don't need a case to have any functionality, but included in the logic. Okay. Yeah, I guess that's the right one. Break. I suppose continue does mean go to the next one on the loop. All right, and I hope this passes. Okay, let's run this. We don't do Boolean semantics yet, so we're going to get an error one way or the other, but we'll see what error we get. 3 less than 4, we don't evaluate that. 3 less than 4 less than 5, we'll probably get a similar error. Yeah. Well, that may be that we just don't have our semantics in place yet. So let's go back up to parser. Yeah, so we don't have anything. We don't have the operator in place. That's why. Oh, and we knew they should have none, but we didn't have the word for it. Okay, this is actually all right. This is kind of acceptance level type thing, but that's something. Let's run that again. The thing is, we don't have any semantics on these operators. Yeah. Yeah. Oh, little difference. Yeah. So, that message could be better, but I think it's catching the right thing. The 3 less than 4 not working is because we don't actually handle that yet. All right. Now I bet we could. Let's find. Well, where's the interpreter? Okay, so I guess what have we done now? Let's see. Allow none for the associative relationship, e.g. A less than B less than C is not supported. Okay. We haven't had a break. Let's just take a quick break, like a very short 2 minutes, and see you then. Welcome back. Okay. Let's see. So we've got these things added in with nuns. That's good. They're added in at the right precedence level and everything. So that's sort of nice. I'm going to say we do that. Okay. Now, remaining operators. Well, okay. Let's see what's involved here. I'm going to go to the actual Elm interpreter for this. So Elm REPL. And if we say 3 divided by 4, we get a float. Yeah. So 3.0 divided by 4, it should be a float. So this operator is number across number goes to float. It always yields a float. So it's different semantics than plus, say. Plus says number plus number goes to number, and it knows if you give me two ints, I'll return an int, and if I get an int and a float or two floats, I'll return a float. So that's one reason we got to be a little different here. Let's see. The operators we need to handle are, well, there's a bunch of them, right? Ampersand, ampersand. We're not ready to do that one. Bar, bar is logical or, right? Well, the booleans are tricky. Anything with booleans is weird. Plus plus is not arithmetic. How's it going to format this? Less than bar, bar greater, bar bar, amper amper, plus 6 left. We got some duplication there. Got overridden, I think, but plus 6 minus 6, that's more like it. Okay, I think that may have been our original. Double equals yields a boolean, plus plus yields an appendable, plus minus star, now float divide, int divide, and percent, an up arrow. Okay, let's tackle those. So float divide is slash, int divide is that, percent, and up arrow. Okay. And if we look to, how about 5//2, it takes two ints and returns an int. 5.0//2, I don't even know what it does. Oh, complains. Okay, so it's got a hard limit of ints on the int divide. 2 to the 3 is a number. 2.0 to the 3 is a float. Okay. 2 to the 3.0 is a float. So number, this is normal, I guess, right? So float to float should be float. Okay. I guess I learned the hard way today. I don't think Swift has an exponent operator. At least not one that works like that. Exponent, and then the percent one. Oh boy. 3% 2. Elm does not use percent as the remainder operator. What does Elm do? Modulus. Well, sen and 2. Boy, Elm has such nice messages, but this one, the difference is how negative numbers are involved. It would be nice if you just told me which one is which. I mean, I probably want this one. But Elm Core latest basics mod by remainder by. Well, let's see what we got here. Oh, well, apparently we don't have an operator by default. Okay. Mod 4. Minus 5 mod 3 minus mod 4 is 3. If you add 4, you get minus 1. You add 4 more, you get 3. Okay, yeah, so that's normal. Normal. And that one's just weird. Okay. Let's see. So, okay, I guess we don't need to do a percent operator. It almost seems like percent should get an error message. All right. So the slash operator always is number to float. That's different. Okay. This is more interpreting. We had our primitive functions and our tests. We don't have a... Let's get rid of that. And we touch the parser. Okay, so let's find our primitive functions. Okay, so convert to, the name could be better. Now the percent, that thing is just an error. All right, let's clarify that. So they only recognize percent. Was that the names remainder by? Okay, this one is number goes to float. Floating point is number. Okay, it's kind of like the others. Number goes to number. Oh, the exponent is number goes to number. The float, the int operator is int to int. No, number goes to number. Right? 2 to the 3. Number, float, float, float. Okay. So number goes to number. That one. Okay, so what's Swift exponentiation again? I think we have to use a method. Currently available in Swift by use the POW function. POW AB is the same as A to the B. Okay, let's start with this one. It's the easiest type-wise. And we may even be able to just add it. Curry. Let's try it. Let's see. Are we testing these primitive functions? I don't remember what we did. Well, we sort of default. We tested convert to. That makes me curious if we can just, do this. Convert to, can I put POW in here? POW F, POW L, POW decimal. Float, float, float 80. Double, double. Decimal to int. We're not really in that case. Float, float. Well, let's see if it takes it. No. Okay. We'll put something wrong in writer test. Okay, so let's test integer power. And I think we wanted, let's see, let's create integer value is let's primitive functions dot int power 2, 3 should be 8, I think. So int goes to int is that. All right, we don't have a int power function. more unlikely. Okay, int goes to int. So that's suitable to pass to convert to. And the POW function that already exists should be useful in the other one. All right, the test should fail. Primitive functions has no int power. Maybe I have to be static. Primitive functions has no int power. Jump to definition. Okay. What's going on here? Symbol table nil, prefix operator primitives. Oh. Zero not equal to 8. All right. And in our, I don't know what you're doing. In here, we want to convert. Oh, well, let's not use that yet. Let's get this working. Okay, so we're going to return power of A, B. Can I do this? Convert to a decimal. Cannot convert expected argument type decimal. Well, I think that's this one. Oh, goodness. So what's POW? Math. Double. Let's try this. Double A, double B. Trying to be closer to the semantics of the underneath stuff. Okay, so that'll kind of get us going. This, I think, is int power. And this is POW. We'll move this one down. Actually, that one can go because he's just not legal. All right, and let's just run this with this. I don't know if we have to do anything else to hook it up. I think that may be it. 2 to the 3. Well, it's great other than 3 to the 4th. Should be 81, right? Oh. Well, 3.0 to the 2.0. It's like it's only returning the first argument, doesn't it? All right, let's see why we're not evaluating. Well, let's break in here and see if we're ever getting called, I guess. Two to the 4. We are not. Okay. Let's... Okay. All right. So we're in a place where the tests pass, but the actual evaluation does not. So let's pick up there next time. I got to cut out a couple minutes early here. I'm hoping it's probably just a connection thing that we don't have the right, don't have the operator knowing that it's that the up arrow probably needs to know that it should map to that other symbol. Oh yeah, no, that's actually we don't really handle those that way. I mean, that's okay for infix operators. Oh, let's try that. Oh, a little quick experiment here. Arrow 2, 3. Yeah. Okay. So that hooks them up for the prefix form of the operator, but we don't handle the infix form. Okay. Prefix works, infix doesn't. Right. Okay. So we will pick up there next time. Thanks for joining me today, and hope to catch you in the future. Have a good evening. Bye bye. Next time is Tuesday, 1 to 3 p.m. Eastern Daylight.